Okay, I'm going to attempt to go over page 19 with you at a request of one of my students. So page 19, number 98 says that Jen measured the growth of a sunflower. In week 1, it grew 2.5 inches. In week 2, it grew 2 3/4 inches. And then in week 3, it grew 3 1/4 inches. How much did the sunflower grow in the 3 weeks? So again, when I'm doing any kind of word problem, I know it's important that I go through cubes, and I keep saying it again and again, that you're not just going through and, oh, I'm going to circle my number. Okay, 2.5 inches, 3, oh, there's another number. Okay, I'm going to go ahead and underline. Okay, I'm done underlining. Then let me box, grew. Okay, so, and now I'm done. No, I keep telling you that you actually then, after you've gone through that part, you get to that E. I've circled, I've underlined, I've kind of boxed some words that might help me with my operation. But you need to go back and review it to make sure they're actually doing the correct operation, because it's not just a key word like how many left and, oh, I'm going to subtract. We learned that in our last unit, that it's the totality of all those words. Sometimes how many are left could even been multiplication or division. So it really is going through the word problem in your totality. So I know that in the first week it grew 2.5, in the second week it grew 2 3/4, and then in the third week it grew 3 1/4 inches. And I want to know how much it grew. Oh, in the 3 weeks I missed an operation. So now if I want to find out in the 3 weeks, it's not just in week 3, but in the 3 weeks. So I actually am adding together all 3 weeks. So when I look at this, I'm going to be adding together my 2.5 plus my 2 3/4 and my 3 1/4. Now you'll see in this instance that I wrote those 3 fractions, or those 3 mixed numbers, going vertically, but if you're more comfortable with the horizontally, it's what you want to do and you own that way. Now, what I should recognize is that any time that I am adding fractions, I have to have that common denominator. So I have 2, 4, and 4. They're not common denominators, so what I'm going to need to do is get them, all those 3 mixed numbers, with a common denominator. And if I didn't know it, I would then list my multiples for 2 and 4. So 2, 4, 6, 8, and so on. 4, 8, 12, 16, and so on. And I go through and look at the biggest number first to identify that common. I have a 4 and a 4, so 4 is going to be our common. I'm sure that most of you recognize that right off the bat, but if you didn't understand it, for larger denominators, you would list your common multiple and find your least common multiple. So in this instance, I'm going to turn them into denominators of 4. So that needs to go there. These ones are already in 4, so I'm just going to drag them straight across. However, now I need to figure out what did I do to go from 2 to 4. So 2 times what got me to 4, and I say times because I'm going up to a larger number. And I should be able to recognize that 2 times 2 got me to 4. So what I do to the bottom, I also need to do the top, so I need to multiply that numerator by 2 as well, and now I have 2 2/4. So I have those common denominators, and now I'm just going to go through and add my numerators. I have 2 plus 3 is 5, plus 1 more is 6, so 6, 4, so your denominators stay the same because you have that common. And now going through and adding your whole numbers. 2 plus 2 is 4, plus 3 more is 7. Now hopefully what you'll recognize is that you have that whole number, but you also have an improper, and you can't have a whole number with an improper, because improper, again, recognizes that it's greater than 1. So you need to regroup that greater than 1 with your whole. So look at it as division. 6 divided by 4. How many times can 4 go into 6? I know that 4 can go into 6 1 time. So I can regroup one whole, and that 1 times 4 means that I took 4 away. Again, 4/4 is 1 whole. So when I do that, I now have 8 whole, and that whole that I regrouped leaves me with 2/4 left over. And again, what do I recognize about 2/4? I should recognize that my numerator and my denominator can both be divided by 2. 2/4 is equivalent to 1/2. So your answer for that one is 8.5. I recognize that you cannot see your answer choices on here, but your answer choice correct for that one is D. Let's go ahead and look at the next one. Let's look at number 99. And I'm just going to erase that, but I'm going to move it up so you can see everything. Okay, when I look at number 99, it says Javier drew the shape shown. For numbers A through B, choose the values and terms that correctly describe the shape that Javier drew. So first I'm going to look at letter A. And letter A says, how many sides and angles does this figure have? So I have two choices, sides and angles, and I need to go through and count both. So they have markings, but what I always recommend is that you mark over them so you make sure you don't double count one or miss one. So I'm going to mark over. I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 sides. And again, what is a side? It's that part that's connecting your two vertices. It's that straight line. So there's your sides. I have 8 sides. And the next part says the angles. So I'm going to count my angles. That's where my two lines meet at the vertices. So how many angles do I have? And again, I'm going to use my marker to go over it. You can use your pencil or pen or whatever. Angles. Here's 1 angle, 2, 3, 4, 5, 6, 7, and 8 angles. And I almost missed that one, so it's good that I go over it so I don't accidentally miss it. So you will see that this shape, this 2D shape, has 8 sides and 8 angles. Now when I continue on and I look at part B, it says, what do you name the figure? So a figure that has 8 sides and 8 angles. And guys, I got to be honest with you that I covered 8 sides and 8 angles when I taught first grade. So this really should not be like a total life pivoting skill. 8 sides and 8 angles. Octo means 8, so that's your octagon. But I'm going to challenge you to think for a moment. Is it a regular or irregular pentagon? And I would really like you to get that because that is something so vital for going into FSA and then also going on into middle school. You need to be able to identify if it's regular or irregular. So in this instance, hopefully you figured it out by now, it is a regular polygon, and again it's an octagon, so a regular octagon, because you can see that when you looked at the shape that all your angles were congruent, they were all the same angle, and all your sides were congruent, they were all the same size. So that congruency, if all my sides and all my angles are congruent, then I'm going to have that regular polygon. If they were different lengths or different angles, that would make it irregular. But again, this is a regular octagon. So kind of getting into recognizing that. And the other thing that you should recognize from the pattern is however many sides I have is also how many angles I'm going to have. Let's go ahead and continue on. I'm going to look at the next one. I'm going to look at number 100. Whoops, I should pay attention to what I'm doing. Okay, on number 100, let's see, can you see it on my camera? Yeah. Okay, so on number 100, Joshua uses a rule for writing the following sequence of numbers. So he's got 1/6, 1/2, 5/6, something, and 1 1/2. What rule did Joshua use? I'm going to go ahead and box that in so it really stands out to me that I need to find something there. 1, 1, 5, 1. I don't really recognize anything yet. So I want to think, what do I know about these fractions? And I'm actually going to think, well, they could all share common denominators, so maybe if I made them into equivalent fractions with that common denominator, then maybe I would recognize a pattern. So that's what I'm going to try right now, and I want to figure out, okay, I have 6, 2, 6, something, and 2. What could that common denominator be? Right, it should be in terms of 6. So this is already in 6, so I'm just going to drop it down 1/6. This is in 6, so I'm going to drop it down. This will eventually be into 6 because we're looking for that pattern with that equivalent fraction using a denominator of 6. And then this last one, 1 and something over 6. So I'm going to figure out what did I do to go from 2 to 6. First of all, I know I'm going from smaller to a larger, so equivalent to you're either multiplying or dividing. In this instance, so I'm going to a larger number, I know that I'm multiplying. So 2 times 3 is 6. And what I do to the bottom, I also need to do the top. So I'm going to take and multiply that numerator by 3 as well. 1 times 3 is 3. So 3/6 is equivalent to 1/2. I'm going to do the same thing here, only that I don't have a clue about that number. And if I were to bring this up, this would be 1 and 1/6. So I don't really completely see a pattern. I see 1, 3, 5, and then I go back to 1, so that doesn't really make sense to me. What could I do to that 1 and 1/6 to help it make sense to me? Oh, you know what I could do? I could take that number and I could actually turn it into an improper fraction so that I can see if there's some kind of a trend with my numerators. So how do I take that mixed number and turn it into an improper fraction? Right, I take that whole number and I multiply it by my denominator. 1 times 6 is 6. And then I add it to my numerator. Again, whole number times your denominator, adding it into your numerator, you would now have a equivalent fraction of actually 7/6. So again, when I'm doing that, oh, you know what? I'm in error. Darn. You know, I just noticed because I was like, this still doesn't make sense. 1, 3, 5. I thought that was going to be 7, but what I did notice is when I went here, I forgot to make an equivalent fraction. It was in terms of halves. So again, going back and checking your work. If I didn't notice something was working, I need to go back and check my work and see where is that error, because there has to be a pattern and it has to make sense. So I kind of went back and I checked my denominators and I realized 1/6, 1/2 is not 1/6. So again, I'm going to go back and turn this into 6. So what did I do to go from 2 to 6? It was just multiply by 3. I did that same thing here. So this would be 1 3/6. Now taking that mixed number of 1 3/6 and turning it into improper. So again, how do I take that fraction and turn it into improper? Right, I should take that whole number times my denominator and add it into my numerator. So 1 times 6 is 6, plus the 3/6 that I already have. I now have 9/6. So again, why do I have that 6? Well, 6/6 is equivalent to 1 whole, and I regrouped 1 whole. So really I had the 3/6 plus the 6/6 that I regrouped for my 1 whole. So now I can look for that pattern. Now I have common denominators, they all have a numerator, and there's no wholes, so they're all in the same kind of a form. No whole numbers. 1, 3, 5, something, and 9. Oh, you know what I've noticed is that they're skip counting by 2s, and they're also doing it with odd numbers. So they're counting by odds. 1, 3, 5, 7, 9. So again, anytime you make an error and you're not seeing that trend, you really need to go back. Don't just guess, but going back and checking that work. So what rule did Joshua use? He used counting by odd numbers. And what is the missing number in the sequence? It is, you could say plus 2 here, by the way. 1 plus 2 plus 2 plus 2. So probably plus 2 is the better here if you're talking about making a table. And then the missing number in a sequence, it would be 7. And again, you take those patterning and tables and graph it on a coordinate grid. So it is important to recognize the actual rule, which would then have been plus 2. I'm going to look at number 101, just making sure it's all showing up on my screen. Okay, the 4 fastest times of a 100-yard dash at a track meet was, oh, that's a larger number. Okay, 9 800ths, 9 1/10, 9 1500ths, and 9 600 seconds. Again, recognizing with place value, when you have that whole number, and then afterwards you have that T, H, T. Tenths, hundredths, thousands. So just remember that in your head, T-H-T, tenths, hundredths, thousands. So now the question is actually telling me, okay, I have these 4 numbers, and the question is actually telling me choose the number that makes the statements true. So it says the fastest of the 4 times was blank seconds. Fastest. What is fastest telling me? Oh, fastest means like the most amount or the biggest amount. So I'm looking for that. Now, I could leave it in this order, but sometimes it's easier to actually line up your place values because you're looking at the largest digit and comparing going to the smallest. So they don't have the place value digits lined up. So what I'm going to do is I'm going to place my 4 decimals and then fill in my numbers. This assures that my place values are going to line up. Line up those decimals first and then go back and plug in your own numbers. So here I have a 9 before the decimal and a 0 after. Here I have a 9 before the decimal and a 1 after. Again, making sure that that 1 falls right in the same place right after in that 10th position. If you drag it all the way over here, again, your place value is not lined up. So keeping it lined up all the way. 9 15 hundredths, and then 9 6 hundredths. So again, when we're comparing values, we're looking at our largest digit first. So my 1's place, I have 9's in the whole thing. I have 0, a 1, 1, and a 0. I recognize that the 1 is bigger, but these both have 1. Like ABC order, since they're both the same, I'm going to move over to the next, in ABC order would be the next letter. Here it's the next digit. So I have nothing here and a 5 here. Well, what do I do since there's nothing there? Again, just like ABC order, there's nothing there, there's nothing there. But here I can actually put a 0 in its place. So I know that that 5 is larger than the 0. 9/10 is the same thing as saying 9 and 10 hundredths. It's equivalent. Add zeros to the end. Equivalent, doesn't matter how many millions of zeros you want to add. So this is my larger number. Again, same number. These two are greater. And then the 5 becomes the greatest. And again, like money, $9.15 is way more than $9.06. Okay, the next one says the slowest of these 4 times was, and again, I already have those numbers, so I'm not even going to move on from that. I'm not going to lift the paper yet. I already have those numbers listed, so I don't really need to write them again on this, but this time just recognizing that I'm looking for the slowest. So I have 9s, I have a 0, 1, 1, and a 0. Well, I know that the smaller number is going to be the slowest speed. So the 1s are already eliminated. I can't use the 1s. The 0s are my smaller. And since these are both 0s, then moving on to your next digit, I have a 6 and an 8. 6 is less than 8, so that 1 at the bottom for the slowest is going to be 9 and 6 hundredths. And the last question on this, oh, you know, I didn't give you a mystery word, so let me give you one now, in case people wait for the very last part. The mystery word is stage, so just write that on your piece of paper. Make sure your name is on it before you turn it in. No honor system here, it's got to be on the paper. Alright, so number 102 says, which number makes this inequality true? So inequality, equality means equal. Inequality, you know, it's not equal, so these are not equal. There's no equal sign. So when it's talking about inequalities, it's really just talking about a comparison. So I need to find out this number is 4,253 and 647 thousandths. And I just wanted to reinforce how to say that in number names because we all get fooled when we get to that decimal, the decimal representing the word and. Read this whole number together and then the place value of the last digit, 647 thousandths. So I need to find something to compare that. And this symbol right here is telling me that this number, 4,253 and 647 thousandths, is telling me that that number is actually bigger. It's greater because the alligator wants to eat the bigger number. Yum, 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 yum. It's his big old teeth. I'm going to eat it. So I need to actually find a number that's smaller here. So again, you're looking at place value 1 part at a time. These numbers are already here. They're already lined up like place value digit. So what I'm going to do is I'm actually going to take that same number and I'm going to line it up just above it. Or you could do the same thing right below it. But I'm going to make sure that I line up place value digits. This is going to allow me to compare a little bit more easily because they're all going to be lined up and I can come all the digits straight down at the same time. So first of all, I recognize that they have 4, 4, 4, 4. They all have 4, so moving on to the next. A 2, 2, 2, 2, 2. Move on to the next. 5, 5, 5, 5. Move on to the next. And again, the next one we all have 3s. So the whole number really in this case is a distractor. It's just to frustrate you. Don't get distracted by how many digits there are. If they're all the same, they're all the same. So now really what I'm doing is I'm looking at my digits after the decimal, and again, I'm looking at the greater value first, so that next digit right after in your tenths place. I have a 6, a 6, a 6, a 6, and a 6. Holy cow, they're all the same. Once again, since they're all the same, moving on to your hundredths place. Well, now they're getting different. I have a 4, a 6, a 5, a 4, and a 3. Well, I know that this is supposed to be the greater number. The 4 has to be greater. So I don't want anything bigger than a 4. The 6 is bigger than a 4, so that can't work. My 5 is bigger than a 4, so that can't work. This has a 4, and this has a 4, so if I wanted to compare the two, I would move on to my next digit, my thousandths place. This one has a 7, and this one has a 9. 7 would not be greater than the 9, and I need this number to be the greatest, so that one's not going to work as well. But again, you could check it. I have a 6 and a 6. A 4, the 4 is bigger than the 3, so this one is going to be greater, and D is going to be your less. So 4,253 and 638 thousandths is going to be filling in this blank, making this one the greater, and that one the less. Again, have a great day. I hope you enjoy this. Let me know if you need anything. Please feel free to post any comments.